today, in our tour of ACT Maths, what we're going to look at is matrices. Now, this is one of the topics that most of you won't have seen before, and like other new topics in the ACT, like complex numbers, logarithms, these are topics people tend to have to learn just for this exam, but you tend not to have to know them in much detail. You just need to have a superficial understanding of how they work and how to know how to do a few things. So hopefully, although it's new, it shouldn't be too intimidating and daunting, and pretty soon you should be able to do any matrix question the ACT is going to throw you. Now, a matrix looks something like this. They're usually a group of numbers surrounded by these square brackets, and I just want you to think about these as each matrix is basically a spreadsheet. So each one of these numbers represents the cell in the spreadsheet, and they just contain information or data. So they might be, for example, just a list of the number of students in different classes. It could be a shop where you have different items of stock in each shop, or the different prices of items in a stock. So matrices are just ways of storing information. However, we don't even need to know too much about conceptually what they are. We just need to know how to do about 4 different operations with matrices, 3 of which are pretty simple. Adding matrices together, multiplying a matrix by a scalar quantity, and working out the determinant of a 2x2 matrix. These are pretty simple things to do. The one slightly more complex operation is multiplying 2 matrices together. This can sometimes trip people up, but as we're going to see, if we divide this process into 3 or 4 pretty simple steps, it's actually not that hard to do. And so this video is going to cover just those 4 operations you need to do with matrices, and that should be all you need to know for the ACT. Now, I want this video to be quite short and quite simple just to cover these basics, so I'll just have 1 or 2 examples of each process, but I'll make another video after this with some questions so you can have a practice and become more comfortable with how to do these for yourself. Okay, does that sound good? Let's get started. So the first thing we need to know how to do is how to add 2 matrices together. And matrix addition is what we call defined only when we have matrices of the same dimensions. So there are 2 definitions there we probably just want to clarify. When something is defined, it's when it works. When it's undefined, it doesn't work. So, for example, if you get math error on a calculator, for example, if you try to divide something by 0, we would say that that's undefined, it's impossible. So something is defined if you can do it. And matrix addition is only defined when matrices are of the same dimensions. And so we define matrices by the dimensions by the number of rows and columns that they have. So in the example here, we can see that the first matrix on the left has 2 rows and 2 columns, so it's a 2 by 2. And the second matrix also has 2 rows and 2 columns. It's also a 2 by 2. Their dimensions are the same, and we can therefore add these together. Just quickly, if you ever forget which one is a row and which one is a column, I always think about rows like a row of books on a shelf, and columns I usually think of maybe like a little Greek temple that has a few columns like that. You see? Okay, great. That's how we can remember what rows and columns are. So if we do have 2 matrices of the same dimensions, then adding them is really simple. You just add the corresponding spaces in each matrix. So in this case, we're going to have 1 plus 3 in the top left corner. We're going to have 4 plus 5 in the top right corner, 2 plus 7 in the bottom left, and 6 plus 8 in the bottom right. And so what that's going to give us in the end is 4, 9, 9, and 14 in the 4 corners of our matrix. Now, some people wonder why we can't add matrices of different sizes. And the way I like to think about it is, if you could imagine that this was maybe a stock room, and we already had 1 CD, 4 pairs of jeans, 2 jumpers, and 6 tops in our shop. And then we ordered some more. We ordered 3, 5, 7, 8 of these items to get a replenished stock. If we tried to add down here 2 extra items, maybe like 4 DVDs and 5 video games, well, where could we add them? It'd be if we tried to deliver them into the shop, there wouldn't be any shelves to put them in. There would be no space for them to go. It would be impossible to fit these into our new stockroom. What we could do is we could change our original matrix like this and put 2 zeros here. And at least now we have space for our additional items. We have room for these new items of stock, and we would be able to add those together. But if you do not have matrices of the same dimension, there is no space for these numbers to fit into, and you cannot add them together, if that makes sense. Okay, great. We're going to move on quite quickly, and like I say, there'll be another video with some more questions. You get to practice this. But the next thing I'm going to look at is scalar multiplication. And this is when we just have one matrix and a number in front of it, which is multiplying the entire matrix. And as you might expect, we just multiply everything inside the matrix by this particular number. So in this case, we have a 4 outside our matrix. And so when we multiply these together, we're going to get 4 times 1, which is 4, 2 times 4, which is 8, 3 times 4, which is 12, and then 4 times 4, which is 16 in each of the 4 corners of this matrix. Pretty simple. Let's just have one more example. So we could have a matrix where we have, I don't know, x in the top corner, y in the top right, 10, and then 20. And we might want to multiply this by 3. And if we do so, we're then going to get a matrix of 3x in the top left, 3y in the top right, 30, and then 3 times 20 is 60 in the bottom right-hand corner. So again, if you get a matrix addition or a scalar multiplication question in the ACT, happy days. These are pretty straightforward processes that we know how to do. That's always a great question if you get that early on in the exam. What can be a little bit more complicated, what we're going to move on to now, is matrix multiplication. And there are several steps to this. It can look a lot at first and people find this very, very confusing. But if we do 1 or 2 simple steps as we go through, hopefully the process becomes a lot more manageable and we'll figure out how to do it. So the first thing we need to know about this is when we can and can't multiply 2 matrices together. So in this example, you'll notice we have 2 matrices of different sizes. They look slightly different. If there's an addition, we would not be able to add these matrices together. They have different dimensions. We could not add them together. But the question is, can we multiply them together? And actually the answer is yes. How do we know? The first thing we want to look at is the dimensions of the matrix and the number of rows and columns each one has. So our first matrix, we have 2 rows, and then we have 3 columns. So this is a 2 by 3. Our second matrix, we have 3 rows, and we have 2 columns. So this is a 3 by 2. And when we write these out, I would always do this. I would write out the dimensions like this, 2 by 3 and then 3 by 2 next to each other. We know that these can be multiplied if the 2 middle numbers are the same. So we draw a box around this. We have 3 and we have 3. The columns in our first matrix match the rows in our second matrix. That means we can multiply them together if those middle numbers are the same. So we have 3 and 3. We can do this. The other thing we already know about this is we know how big the resulting matrix is going to be by looking at our outside number. We have a 2 outside here and a 2 outside here. And so what that means is the matrix we're going to get out of this multiplication is itself going to be a 2 by 2. So not only are we multiplying 2 matrices of different sizes together, the product of these matrices is going to give us a matrix of, again, a totally different size. But we know how to do that, and often in an ACT question, this would get you halfway through to the answer already because you would already be looking for an answer choice that was a 2 by 2 matrix. The next thing we then have to do is figure out how we actually do the multiplication. And this again can be quite complicated, but I would do several things to make it a little bit easier on yourself. So the first thing I would do is I would put a ring around the first row of your first matrix, and then your second matrix I would put a ring around the first column. And what we're going to do is we're going to move along that first row and down that first column, multiplying these 2 numbers together. So we're going to get 1 times 7, then we're going to add that to 2 times 9, and then we're going to add that to 3 times 11. So that's going to give us 7 plus 18 plus 33, which is 58. Great. Well, where do we put that number? And then we think we went along our first row and down that first column. So that's going to give us the top left position in our new matrix, and that is going to be 58. Okay. So now I hope it also begins to make sense why those middle 2 numbers, those 3s, had to be the same, because we need to multiply these 3 things here with these 3 things here to be able to do the multiplication. And then we can run through and do the same thing for all the other slots. So if we wanted to get the top right corner of our resulting matrix, we're going to have to go again along the top row, and this time down the second column of our second matrix. So this is going to give us again 1 times 8 plus 2 times 10 plus 3 times 12. And so that is 8 plus 20 plus 36, which gives us 64. And so we can drop that into that section of the matrix there. If then we wanted to get the bottom left corner of our resulting matrix, we want to think about going then this time along the second row of our first matrix, but again down the first column, because we want the first column of our resulting matrix. So this is going to give us 4 times 7, plus 5 times 9, plus 6 times 11, and again that's going to give us 28, plus 45, plus 66, which is 139. And so we can put 139 in that particular slot there. And then lastly, I think you see where this is going, we need the bottom right-hand corner of this matrix. So we're going to go again along the bottom row of our first matrix and down the second column. And so we're going to get 4 times 8, plus 5 times 10, plus 6 times 12. And that's going to end up with 48, plus 50, plus 72, which I'm doing this already. I'm not doing this in my head. I already worked it out. It is 170, which goes in our bottom right corner there. Okay, so I don't want to dwell on too many examples here because I do want this to just be a relatively short video where you just go through all the process. But let's just do one more matrix product because this is probably the most confusing or hardest thing to do when it comes to matrices. So in this example coming up, we now have 2 matrices, and again we need to figure out their different sizes. Can we multiply them together? Well, we need to think about how we would know. The dimensions of our first matrix, this has 1 row, 4 columns, so it's a 1 by 4. And our second matrix, we have 1, 2, 3, 4 rows and 2 columns, so it's a 4 by 2. So we know we can do this because the inside numbers, the 4s, are the same. And then what size are we going to get? Well, again, we get our outside numbers and we have a 1 by 2. And so we're going to get a very, very small matrix out of this with just 1 row and 2 columns. If you want to pause it to see if you can remember how to do the multiplication yourself, quickly do that if you want, and then we'll go through that process itself. Okay, so how did you find that? And again, I find drawing rings around the matrix helps us figure out what we're trying to add together. So again, we're going to go for the first number, we're going to go along the only row and down the first column. So put a ring around this and a ring around this. And we're going to get 3 times 1 plus 4 times 0 plus 7 times 6 plus 2 times 2, which will give us 3 plus 0 plus 42 plus 4, which is 49. And then again, for our second space, it's going to go again along the first row, down the second column, to get 3 times 4, plus 4 times 2, plus 7 times 3, plus 2 times 0, which is 12, plus 8, plus 21, plus 0, which is 41. And so that completes that matrix. Again, I'll give you some more questions later in another video just to really go through this, because this process is really important, especially remembering how to compare the dimensions of your 2 matrices to figure out if it's defined, undefined, what size you get. These are all super important processes with matrix multiplication. But the last thing I just quickly want to go through, and then we're done with this video, and this is all you need to know about matrices for the ACT, is figuring out the determinant of a 2 by 2 matrix. And you'll see in the example we have here, rather than the square brackets we've normally had around matrices, we have these straight lines, which you might also recognize as the absolute value, the magnitude of a vector, the modulus of a complex number. Whenever we have these straight lines, we really want to know just how big something is, not necessarily the dimensions of the individual components, but can we put a numerical value on just how big this is? And the way we do it at the matrices is kind of strange, but relatively straightforward. I would draw a little line between the 4 and the 2, and we're going to do 4 times 2. And then we draw another line down from the 3 to the 1, and we're going to do 4 times 2 minus 3 times 1. And so that's going to give us 8 minus 3, which is 5. So we go from top left to bottom right, multiply them together, and then we subtract the top right to bottom left. So we get one more example just to kind of nail this process down. Here we have maybe the absolute value of 8 to negative 4 and 9. When we try and do the determinant of this is going to give us 8 times 9 minus 2 times minus 4. And so we're going to end up with 72 minus 8, which gives us 80. And so they are the only 4 operations you need to know how to do with matrices. If you want to go and do some questions, I'll put another video up there. And then otherwise, that's it, and that's all you need to know for now. Okay, so they're the 4 basic matrix operations you need to know to do any matrix question on the ACT. Now, if you want to do some practice on those, the next video I'm going to upload will give you some practice questions for each of those 4 operations so you can hone your skills, see how that goes. If you're still having trouble with matrices or something you're still unsure about, try and rewatch this video to see if it works best the second time around, or you can get in touch with me for some lessons. I give lessons on all aspects of the SAT and ACT, so if you want more help with matrices or just anything to do with any section of these exams, please do get in touch. My website is in the information below, and I can do lessons in London, in Glasgow, or over Skype, so I can help you wherever you are, and I'm always available to help you if you need it. Please obviously like and subscribe to my channel. Any questions or comments you want to make, please leave them below. I will try and read them when I get time. If there are any videos that you want me to make, I will eventually be covering all aspects of the SAT and ACT syllabus, but if there's certain questions you want me to look at, or certain topics you want me to get to sooner, please do ask, and I will try and get through to them as soon as possible. Again, please do like and subscribe. Hopefully I'll see you soon, and get in touch if you want any more further help. Okay, thanks very much. Thanks for watching.